Okay, problem 1, or not problem 1 actually, I think it's problem number 3, but just, this is from chapter 3 exam. You've got tangent t sine t equals secant squared t minus 1 over secant t. And I'm going to need that. Okay, so I need to write sine of t in a way that I get a tangent in the numerator of a fraction here. So if I take the tangent over the secant, and let me explain that that is the sine over the cosine over 1 over cosine. And if I use what I know about division of fractions, that's really sine over cosine times cosine over 1. The cosines will cancel, and that's equal to sine. So this is equal to the sine of t. Now the reason it's useful over here is because if I write tangent of t times tangent of t over secant of t, the numerator then becomes the tangent squared of t over the secant of t for the denominator. Now, how is that helpful? Well, if you'll go to your identity sheet, you'll see that 1 plus tan squared t equals secant squared t. So tangent is equal to secant squared minus 1. If you just move that over, you're going to have tangent squared t equals secant squared t minus 1. So the next step would be to write that as secant squared t minus 1 over secant of t. So there you have verified that identity. Okay, this is number 4 on the chapter 3 test explanation. It's cotangent squared t over cosecant t equal to cosecant t minus sine t. So the first thing I do is I notice that that is part of one of the Pythagorean identities. So I go to my identity sheet and I realize that I can replace cotangent squared t with cosecant squared t minus 1. That's my first step, and it's a Pythagorean identity. My next step is to separate. I have 2 parts to my numerator, 1 to my denominator, so I'm going to separate that into 2 parts. So I'm going to use the same denominator, cosecant squared t over cosecant t minus 1 over cosecant t. So my reason there is that I separated it. Next, I'm going to divide out the common term in that first fraction, and it's going to leave me with cosecant t minus 1 over cosecant t. I didn't have to do anything to the second fraction. My reason there is I divided out a common term. Then I have what I'm looking for, cosecant t minus sine t. I switch this out using a reciprocal identity. Number 5 says negative cosecant t over sine t plus cotangent t over tangent t equals negative 1. The first thing I'm going to do is I'm going to write this as negative cosecant t. You can think of it as negative cosecant t times 1 over the sine of t. And 1 over sine is really cosecant, so you can make that transition here. Plus cotangent of t times 1 over the tangent of t. Well, 1 over tangent of t is the cotangent of t, and that's using the reciprocal identity. I'm not sure how many steps they put in there, but that's the process we need to go through. Then you need to multiply those together, and you're going to get negative cosecant squared t plus cotangent squared t. We've multiplied and we've used the Pythagorean identities to come up with negative 1. Number 11 from chapter 3 test. We're using you are using the sum formula here, and that's the sine of 35 plus 55, which is the sine of 90. So your first answer is going to be 90. Then it asks you for the exact value. Well, you need to look at your unit circle. 90 degrees is located right here. At this location, the point is 0, 1. Sine is y over r, so it's associated with that value right there. So that next answer is 1. Number 12 from chapter 3 exam. cosine alpha plus beta times cosine beta plus sine of alpha plus beta times sine beta. We can identify that this is one of our cosine and sine sum or difference formulas, and by comparing it with our identity sheet, we realize that this is where they are doing the cosine of the first term minus the second term. But what they want us to do first is they want us to let x equal alpha plus beta and y equal beta. So that'll give us a little bit different problem. The way it comes at us, it's now saying cosine of x times cosine of y plus sine of x times sine of y. Then I can simplify that into the cosine of x minus y. Again, that's using the sum and difference formulas. And then I can substitute back in alpha plus beta for x and beta for y. And as you can see, the betas will cancel, and my answer here is cosine of alpha. Number 17 asks us to choose the sign for the cosine of 163 degrees. Here's its formula. You have to make sure you're choosing the sign for 163 degrees and not 326. 163 degrees is located in quadrant 2, where x is negative and y is positive. And since cosine is the x over r, we need to choose the negative sign for that one. Number 20, we're asked to verify tan of alpha over 2 equals tan alpha over secant alpha plus 1. So I'm going to my identity sheet, and I see that there are several things that tangent of alpha over 2 could equal, and one of those is sine of alpha over 1 plus cosine of alpha. And then if I go through and I divide the numerator and the denominator by cosine, so I'm going to divide everything here by cosine, sine of alpha over cosine alpha, 1 over cosine alpha, plus cosine alpha over cosine alpha. In the numerator, I would have the tangent of alpha. In the denominator, I would have 1 over cosine, which is the secant of alpha, and then cosine over cosine is 1. So then I have verified it. Number 24, I'm going to use the sum to product formula. So when I do that with the numerator, it turns into 2 sine of 4x plus 12x over 2 times the cosine of 4x minus 12x over 2. When I do the same thing to the denominator, it's 2 times the cosine of 4x plus 12x over 2, the cosine of 4x minus 12x over 2. These are going to cancel. I'm going to think of that as one big fraction, and I'm going to cancel the things that are in both the numerator and the denominator. So those things get canceled. So this is sine of, let's see, 4 and 12 make 16 over 2. So this is the sine of 16 over 2 which is 8x. I'm going to change that to 8x. And the same thing in the bottom is the cosine of 8x. And when you have sine over cosine, that's the same as having the tangent of 8x. So that's how that one's answered. 25 is very similar to 24. We're still using the sum to product rule. I've expanded the numerator and the denominator, and I see that I have things that are in common, so they're going to cancel, and we're going to have the sine of 5x plus 7x over 2 over the cosine of 5x plus 7x over 2. So that's going to give me 5 and 7 is 12. 12 divided by 2 is 6. Sine of 6x over the cosine of 6x, which is really the tangent of 6x, which is what I'm going for there. It looks as though 26 and 27 are very similar to 25, so I'm just going to let you work on those. They'll follow that same pattern, and we'll go on to number 29. You need to factor on number 29, and this is like factoring backwards FOIL from back in algebra. So this is 2 cosine x and cosine x. The factors of 5 are 5 and 1. I want to use the negative with the 5. That's going to give me negative 10 plus 1. That's going to give me that negative 9 in the middle. And then when I factor, I set these equal to 0. So 2 cosine x minus 1 equals 0. Or cosine x minus 5 equals 0. Solve for cosine x. So I'm going to add 1. 2 cosine x equals 1. Divide by 2. Cosine x could be 1/2. That's okay. We can have that value. Add the 5 to both sides. Cosine x could be 5. Okay, this one you can't use. Cosine and sine both have to stay between 1 and negative 1. So we're going to X that one out because it can't be used. 32 said, where could tan x equal 0? Well, tangent of x is y over x. So we're looking for places where y is equal to 0. Y is equal to 0 at 0 pi, and again at pi. So it is all the multiples of pi, including 0 pi. That's one of the multiples. So that is your answer for 32. Number 33 says the sine of 2 theta is negative square root of 3 over 2. Theta is between 0 and 2 pi. So we have to think about 2 theta is going to be between 0 and 4 pi. So we're going to find our answers, and then we're going to have to go around the circle again to find a couple of extra answers. So if you are at 4 pi over 3, you have a sine of negative 3 over 2. That's coming from the unit circle. So that's where I get, well, 2 theta could be equal to 4 pi over 3, but I want to solve for theta, so I'm going to multiply both sides by 1/2, or either divide by 2, and that's going to give me theta is equal to 4 pi over 6. Now I'll simplify that, 2/3 pi, okay? I also have 2 theta could be 5 pi over 3, because there's another location where the y value is negative square root of 3 over 2. Again, I'm going to solve for theta by multiplying by 1/2 on both sides. So theta could be 5 pi over 6. So those are my first 2 answers within the first trip around the circle. Now, if you make another trip around the circle, you're going to add some pi to that. So it'd be, if you added another pi to this, plus 6 pi over 6, that would give you 10 pi over 6. Which would be 5 pi over 3. And if we added another here, we would get 11 pi over 6. So we have 4 answers here, and that is our number 33. Those 4 answers were 2 pi over 3, 5 pi over 3, 5 pi over 6, and 11 pi over 6.